So today we're going to be dividing rational expressions, and it's just multiplying rational expressions with one extra step. Reminds me of my favorite restaurant. You know what my favorite restaurant is? You'd never guess. What do you think it is? Ah. Man, we got an Applebee's hater. What's it? Oh my god. Makes me this problem makes me hungry just thinking about it. KFC, that crispy golden goodness. Oh my god. Oh my god. You know what I'm saying? You know why? You know why? What's KCF stand for? Keep. But every time I see these problems, for one reason or another, I think of KFC. Oh my god. Golden, crispy. Mm. Yeah, you gotta tell Optimus Prime down the hall there. Chill. Chill. Okay, so what do I mean by this? What do I mean? The only difference between multiplication and division problems, the only difference is that the first initial step, you keep the first fraction, you change the sign to multiplication, and you flip the second. That's it. Otherwise, it's all the same. Change, flip. Keep, change, flip. Change, flip. If this were a short answer question on your quiz or test, which I'm going to try and get another one to you before our marking period ends in 2 weeks, you get 1 point for just knowing that. 1 point. If you don't know how to factor, you don't know how to do anything else, you get 1 point for this. That is nuts. Top times top. This is just how I do these simple ones because I think it's easy and I can use my calculator. Bottom times bottom. And then what does that become? Look, the 4s will reduce down to being 1s. So I'm going to leave 1, 1 on top. And then we have 3 z's on the bottom and 1 z on the top. What happens to them? Yeah, we get z squared left in the bottom. Do you understand how that took place, or that just screwed with people? You guys are good? Okay. All right. Let's talk about reducing this by rules of exponents. Suppose you have 4z over 4z cubed, right? So you do, this is a 1. The 4's cancel, you get 1. Z to the first minus 3 is 1z to the negative 2, right? And that is the same thing as this. It's cool if you want to do it that way. These simple ones where there's nothing to factor or stuff like that, I always do like keep, change, flip, and then I top times top, bottom times bottom. Let's get to factor. Let's get to factor. Let's go just to the next page. Right? Let's pick out something way harder. Way harder. Really? 3's that hard? Oh, because that's just lots of stuff? Okay, let's try 3. Seven x squared y cubed divided by 9ab, and then that in itself divided by 14x squared y, 3a squared b squared. Guys, step 1, you get 1 point for this. What is it? Keep, change, flip. Keep the first one. There's nothing to factor in these, so we're going to take a different route than in the other problems. Keep, change, flip is always that first step. Flip this second one, so 3a squared b squared, 14x squared y. The next step for these ones is we're going to do top times top, bottom times bottom. So that's going to be 20, whoops, too fast. It's going to be 21 a squared, and I always write them down in alphabetical order, b squared, x squared, y cubed. You don't have to. At the end of the day, you will, but you don't have to write it. And then 9 times 14 is 126. So that's 126 a b x squared y. Guys, who remembers how to reduce stuff in their calculator? How do you reduce this down? Divide what? What's up? So we're just going to reduce this. We're just going to reduce this numerical aspect of the fraction, okay? Because the rest of it, it's all variables. You can't plug those into the calculator. Who got the answer? What is it? Close. 21 divided by 126. I think you might have flipped it upside down, Jamie. Right? Now, you don't put that decimal down. Math, convert to a fraction, you get 1/6. 1/6. Okay? So this equals 1, and the 6 is going to be on the bottom. Right? Now, what do we do with the a's? Do you want to subtract them, or do you guys want to cancel like in algebra? Which one's easiest for you? Subtract? Okay, let me take that away. Let me take this away, and we will do it this way. So then we're going to get a squared minus 1, because there's 1 over here. Yeah, you can also cancel. We'll just do it this way, because some people want to be doing it just like we've been taught. But you can also just cross them off. Right? That's b to the first. What do you mean? If wherever there's more of them. Like, there's only 1 in the bottom, so that one gets eliminated, and then whatever's left on top stays there. Okay. And then it's going to be like y cubed minus 1. Is that confusing for you? For some people? Yeah? If it is, I can show you another way. Right? Let me just solve this so we have a video of us solving this, and then I'll fix it. I'll show you another way. So this is going to be a 6th a b. That's going to be x to the 0. That's just 1. And y, that's going to be just y squared. So how do you write that down? I mean, you could leave it like this. This is fine. Or these are all in the top. Notice how I'm writing them down on my paper. That's why I'm a big, proponent of neatness and organization, and why I'm using lined paper for all your notes. They're all written up on this bar. They're essentially a over 1, b over 1, y over 1, and they're all being multiplied together. Right? So that's just a, b, y squared over 6. You'd have to be able to recognize them all out. Yeah. Okay. All right. Now, we're going to go back for 1 second, and we're going to do something, right? I'm going to erase this. Is that all right? Guys, so here's how I was talking to Miss Vestal about how she's been teaching her class. And here's how I would like to show you how she said her class understood it best. The 21 over 126, no matter what, you're going to do the same way. That's 1 over 6. But what does that 2 up there in the exponent spot mean in terms of math? There's 2 a's, and what is taking place between them? There's multiplication, so let's just write it out. When in doubt, write it out. There's 2 b's, and they're being multiplied. There's 2 x's, and they're being multiplied. And there's 3 y's, and they're also being multiplied. The bottom, right? We got 1a. We got 1b. We got, yeah, I've showed this to you. You're allowed to use that when it's all multiplication. If there's addition or subtraction, you can't do it. So this cancels with this. This and this and this and this. That's why there's no x's. This and this, this and this. And then you can just count up all that's left. All in their spots. Yeah. A, B, and 2 y's. And there's nothing but a 6 left in the bottom. Very nice, buddy. Yep. The first step for all of these problems, for division problems, is keep the first one. Change the division sign to multiplication. And flip the second one. Just flip it upside down. Now you have some stuff. You have some polynomials that are separated by addition or subtraction. You have to factor them. How do you factor them? They're weird looking. Okay. 25 minus a squared. What is that? Yeah, it's the difference of two perfect squares. It's 5 minus a, John, and then what else? 5 plus a. Very good, man. Very good. Then we got a cubed on the bottom times a, and we got, and I'm going to group it together, put rubber bands around it, 5 minus a. After you do that, you just do cross-canceling. 5 minus a cancels with 5 minus a. This a cancels with one of these three a's and leaves me with a 2. And you get 5 plus a over a squared. All right, so what do we do? 1 point for sure you can earn out of 4. Jamel, you're the man. 1 point, you've just won. Change the symbol. Whoops. That's where everybody makes a mistake. 5x squared minus 45 all over 3x minus 12. The next point can be earned for the following. Don't freak out if you don't know how to do some of the things. But if you know how to factor others, please do those first. This one on the bottom is really hard. But this, what's 3x minus 12? What's the GCF? 3. Pull that 3 out. There you go. There's one of them. And you see, that might give a clue as to how the others can be factored. How about that one on top? 5x squared minus 45. Does it have a GCF? Let's pull that 5 out. That's 5 times, yeah, x squared minus 9. Right? Now, x squared minus 9 gets factored into being what? Yeah, now, so this is how I do my work. So this is what I did. Instead of rewriting the entire problem over, all I'm going to do is scribble this out and put x plus 3, x minus 3. Okay, maybe it's not such a good idea to scribble it out just in case that's wrong, because then we're going to lose all our points. But just make some mark, like hold on 1 second. Oh, let's put this. This is x squared minus 9, and maybe we'll just put x plus 3, x minus 3 on top of it. However you want to do it, that's fine by me, right? Okay. There you go. Now, we have to factor this over here. What's one way you could do it? It's the most complicated of ways. Everybody sucks at it. The AC method. Of course, you could spend the time doing it, but you can be sneakier, right? The whole point of these problems is that some of the stuff cancels with others. So maybe by factoring out parts of the problem, you've gotten hints as to what could be in the parentheses. What do you think one of the things is? Yeah, one of the things is probably going to be x minus 3. We're going to use guess and check at it, okay? What does the other one have to be? You know what I'm saying? Do you get that, or should we practice our AC method? Dave? Does not matter the order, because multiplication has this property of being commutative, okay? Okay, we guessed and checked at it. Maybe that didn't work out for some people, so let's not only go that route. We're going to take this, we're going to break it off to the side over here for just a second, give us a little bit of room, okay? And we're going to do it. So 2x squared minus 7x plus 3. You're going to factor it using the AC method. So what's step 1? Multiply this one and multiply this one. That gives you positive 6x squared. Give me two numbers that multiply to be negative, multiply to be 6x squared, but add to be 7x. Minus 6 minus 1. Sub those in directly for the middle area over here. So 2x squared minus 6x minus 1x plus 3. So this comes down and this comes down around it. Factor by grouping. Take out the greatest common factor. 2x comes out of those first two. You get x minus 3. Negative 1 comes out of these. You get x minus 3. And then you take the 2, you take this and this, put them together in one parenthesis. 2x minus 1. You take one of the other ones, and it's factored. Don't worry, by the way. I know people are terrible at this, so that's what all your take-home quiz is this week. You're just factoring, nonstop. Now, like I said, you could do it this route. Look at all the extra energy we just expend on it, though. You know what I'm saying? Guess and check. I mean, Jamel, it's just as its name suggests, and that's why some people like me don't really like it. I don't like guessing at stuff and hoping I'm right. But you could say to yourself, 2x is in the front of this, right? There's only one way to make 2x squared, right? Because it's prime. 2x and x. You know what I'm saying? There's only one way to make 3 at the end. That's also prime. 1 and 3. The question is where do they go and what kind of signs go with them? And you might have to play an experiment with the negatives and whether the 3 goes with the 2x or whether, you know, it goes by itself. If you're guessing and checking, though, it narrows it down because you factored this up over here, right? So it's most probable it will end up by itself because it's going to cancel with one of those. Now we just reduce, and that's it. Let's do reduce, 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 reduce. That's it. We're just going to get 5 x plus 3 all over 2x minus 1 times 3. That's our answer.